Yeah, so welcome to the event of a brief introduction into mapping of complex systems by system thinking and system dynamics approaches. I first begin with my talk, then I would introduce my co-speaker, Professor José Julio Gonzalez, and then we end up with the discussions. So the first part by me would be going into the topic of using the participatory system mapping approaches to analyze complex systems for the aim of policy advice. And if you have handle with policy advice, you have more or less two very different strategies. You have ex post policy assessment, assessing the policies which were implemented in the past and having a look how they worked, and ex ante policy assessment, to think about how policies might work in future if they are implemented. We want to focus on the right one, so the ex ante policy assessment. In policy assessment with ex ante, we have very different approaches and methods, where I have here a very rough overview about this. So we have this impact assessment, this classical impact assessment, where you calculate the impact of a policy for a single dimension and make this perhaps multi-criteria, but you really have a focus on one dimension per one dimension. You have the cost-benefit analysis, where you calculate the expected costs and benefit of a policy, which is mainly economic, but of course also ecological and social. You have the multi-criteria analysis, where you try to weight the different criteria, different impacts a policy might have, and then give them a ranking or a value, especially if you compare different policies which you can use. Then you have the very classic, and I think the most common part, the expert feedback. So really from science, government, and praxis, by implementing reports, interviews, workshops, Delphi methods or citizen panels as more advanced techniques. So different kinds of getting the knowledge from experts, what they think is the policy useful or not. Then you have the more or less, I would say, niche up to now, the systemic approaches, which consider how the policies affect the complex reality at all. And they also include nonlinear dynamics and also the unintended side effects a policy might evoke. What are the requirements for approaches to analyze complex impact of policies? And this is especially for transformation processes, where you don't know how policies change society and behavior. Therefore, you have two things. First of all, they should consider the complexity the policy is affecting. So how the complex reality is changed by the policy. So also dynamic behavior of the complex systems, which is in general not linear in change. And on the other side, you have the consideration on the impact on the actors. So that means the policies are designed to change behavior, to change society, especially if you go through transformation processes. So at the end, you end up with complex social systems, which make it even harder, because you can also have complex systems without social components, but this one is, let's say, the top of the difficult approaches. So dealing with complex social systems, we have different approaches to analyze these, which we have here in an illustration from a project, from a publication, where you have from quantitative to qualitative on the left side, and on the x-axis from aggregated to detailed, different kind of approaches, general approaches, where you can use different kinds of methods. So starting from qualitative and more aggregated, so really having a greater look on the whole issue, you have the large toolbox of systems thinking, where different methods and approaches are included, which I present two in a few minutes. Then you have also event tree analysis as a more or less simple technique, dynamic pathway dynamic adaptive policy pathways, game theory and stochastics going to quantitative, and then this, let's say, for most common ones, and that is in the quantitative and more advanced techniques, the system dynamics modeling, agent-based modeling, and data-driven empirical models, where you don't know, let's say, the physics behind it, but you know how the input and output are correlated or were correlated in the past. The challenges of complex systems are manifold. I also want to go into some major issues, and the first one, and I think the prominent one, is that cause and effect are often separated in time and space. This means that if you implement a policy in the society, you of course do not have the impact tomorrow, but it has a strong delay depending on the policy, which is also more than 5 or 10 years. So that's quite hard because humankind is not good with dealing with delays. And also, inaccurate mental models can lead to incorrect problem-solving strategies. That means mental models, so the system understanding we have in mind, how we understand the complex system, is never complete and never, let's say, good enough to solve complex problems for our own. And this can lead to complete wrong problem-solving strategies and policies. Collecting and analyzing more data does not necessarily change the underlying system structure behind the problem. So that means that if we collect more data and try to understand it, we perhaps, with the wrong approaches, do wrong conclusions about the problem causing this. And complex system modeling is one approach to understand the interactions between system structure and the induced system behavior by this system structure. And in the next few minutes, I want to give you an overview of some approaches to model complexity, and want to start with the qualitative ones. So that which cannot be time resolved in the narrow sense. And here, the system thinking toolbox is, I think, the most common ones, which focus on system interrelationships, so really the complex interrelationships in a system, and of course, nonlinearity issues. So here's a very nice overview how these system thinking approach is working. So it really focuses on the interconnectedness in the system, on the circularity and not linear time resolving or development issues, on emergence, on the whole and not the parts, and also very important on the synthesis and really the aggregated view on the system and not the deep analysis of system parts. And at the end of these relationships in the system. So the methods of the system thinking toolbox are concept maps, causal loop diagrams, fuzzy cognitive maps, mind maps, and so on. Starting with the, I think, most easiest one, the mind maps, they have the aim that they show the interrelationship of one central subject area without any issues on dealing with dynamics. And here is an example where you have the impact of global warming, and then you have the more or less tree root diagram where you see the main components and how they split up in different things. So this very visual technique helps to understand what, for example, if you have impacts of a policy, what different impacts on society and economics and so on do they have. You can also create a mind map to create a mind map, which is quite funny. So you have different opportunities to that. And the good thing with this is that you get a very quick overview of all the issues which are connected with this. The more advanced technique is the causal loop diagram, where we try to analyze the nonlinear complex system, so the nonlinearity, but in a very qualitatively way. So this means that we don't end up with simulations, but we get these informations from feedback loops. And the feedback loops are in the system structure, and this is where the focus is to understand the system. So as I said, the identification of feedback loops is quite important, which I show you in a few seconds, and then on linear system behavior. It visualizes the complex system and, very important, where the policy might have an impact in the system. So this is shown on the right one with the green arrows and the green connections, which I also will discuss in a few minutes. And it also shows with these interconnectedness where side effects may occur. So where a very well-intended policy can trigger effects which are not intended and not good for any social development. So to explain you quite in a very rough way how these feedback loops work, the linear causal relationship here, for example, of the attractiveness of a quarter for residents, and the vacancy rate is that the higher the attractiveness of a quarter is, the less vacancy is in the quarter, and it will rise. So the vacancy will go down when the attractiveness rises. From a causal loop diagram, nonlinear one, you end up with polarities, and the plus means that if you start with if you have a higher attractiveness, the rental prices go up. So both go in the same direction. That's why it's a plus. If the rental prices are getting higher, the residents with low household incomes move out of this district and are forced to move out, and the vacancy goes up in the quarter. And this increase in vacancy leads to a decrease in attractiveness. That's why the minus. Input and output are going in the different opposite direction. And at the end, these polarities, so plus, 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 minus, leads to the information that this is a balancing feedback loop. And this is important because this system is more or less stable, because if the attractiveness is going too much up, then the poor households, poor residents will move out, the vacancy goes down, and the attractiveness goes down again. So it's balancing, it's more or less stable. But of course, you have also the moving in of residents with higher household incomes, because the attractiveness rises, they move in, and they, of course, lead to the effect that the vacancy is going down. And this, as you can see it here quite bad, sorry, minus and minus gives a plus, and this means that this feedback loop is reinforcing, and at the end leads to the effect of green gentrification, which means the attractiveness is rising because of the greener quarter, for example. The poorer households are forced to move out, and the rich ones are going in. So that's a very quick and simple visualization of this effect, and explains how balancing and reinforcing feedback loops work, where the focus of causal loop diagrams is. This I will not go into detail. You can find this also in a publication if you want. This is just a very, very basic example and does not reflect the complexity at all. It's a very simple causal loop diagram, even if it's a bit hard to understand. But here, let's say the motivation of the real estate company to implement adaptation measures for drought and heat, so sponge city adaptation measures, is in the central, and the effect on the attractiveness of the quarters for tenants. And with the green one, we test economic policy, a legal policy, a regulatory, and an informational policy, and show what feedbacks they add, or in which feedbacks they are having an effect. And as I said, due to the time constraints, I will not go into detail with this, but this is how it works. So you create your system, and then you see where the policy acts into the system and intervenes in the system. The much more advanced technique and much more time effort technique is then the simulation techniques, so the quantitative modeling approaches, which are system dynamics and agent-based modelings, and of course also empirical modelings and other stuff. So where we end up with quantitative models and or simulation models. This means that you try to analyze really the nonlinear time-resolved dynamics complex system by using, of course, scenarios. That's important. Scenarios, because the future is unknown. That's why you have to use scenarios in all these ex-ante policy assessments. And with system dynamics, for example, this is then the system, the stock and flow diagram, the system dynamics model for the causal loop diagram I showed you before. And this then ends up, if you implement the different policies, in a very nonlinear behavior of the system depending on the policy. And on the other hand, you can also make agent-based modeling, which is then, I would say, the lens of system dynamics, because you focus really on the discrete behavior of agents. So how agents, how persons, or individuals or groups behave and change their decision if a policy, for example, is intervening in the system. So this is more or less for heterogeneous analysis of behavior for policy assessment. And you can see here also on the diagram that policy is more or less a shock for the system. So it's really, you can see it as a shock, which is hopefully intending in the right direction, but it changed the system. It's also, of course, intended to change the system. And you can do with these modeling approaches a deeper analysis how also tipping points and so on are occurring. As I said in the in the title, I have also the approach, the focus on participatory system modeling. What I mean with this, I like this elephant very much. I think most of you know who were in presentations from me and know this elephant and this graphics, because it explains this participatory modeling quite well. All these experts are, let's say, describing or investigating one part of the system elephant. And they are, of course, coming to very wrong conclusions what this might be, because they do not bring together their expertise and their investigation results. And if they were brought together, they would perhaps describe the complex system elephant much better. So the advantages of this method is that you involve the very different system knowledge of experts, of also praxis, of government, and so on, that you also get, as a second part, a higher acceptance of the model. Because if the experts or if the policy counseling is involved in creating this model, they will accept the outcome of this model much better than if you would only say, oh, my model shows this, have a look. And also, it's an opportunity to quantify or semi-quantify the model, because you ask in this spaghetti diagram, in this causal loop diagram, which are the most important connections, and what are the most important feedback loops in the system. The disadvantages, of course, are time, as for all other participatory approaches, and that you, for example, cannot collect really decision makers, but the counseling people for these, which is quite hard, because at the end you end up with at least 3 workshops to do such an exercise. Very important is also that the facilitator quality is very crucial to get a very good causal loop diagram, and also the system analysis you want to have. And that the results depend very much on the individual participants, of course. If you would do this experiment, for example, with one from the Green Party and one from CDU or from AfD, then you will get up a very different system model. So that's the issue for this. But of course, sorry, the last one you can get if you make very much these part and before starting this group model building participatory modeling exercise. So the process for group model building, so for this participatory modeling for creating a causal loop diagram, CLD, are that you first of all identify the problem. That sounds very trivial, but it is not, because first you have a very fuzzy problem, and then you will really end up asking what is the direct specific problem in this complex system. And in the second step, you analyze then what I said, the relevant stakeholders, experts, citizens to implement, which are involved in the problem and which can solve also the problem and create the causal loop diagram. In the first workshop, you end up like this, where you find the variables of the systems together. So you ask the persons to find the most relevant variables, which are affecting the system. And this is quite good because everybody is then connected to the model, and everybody has a content in the model. The second part is then a second workshop, also 3 hours, more or less, depending, of course, on a lot of things. And then you do this joint modeling where you end up with like this. So you go out of this workshop and also the participants and know that the system is complex. But that, of course, does not help at the end. That's why the modelers are going then into their offices and doing a deep analysis of this to identify the feedback loops. And in the third workshop, try to find the leverage points and interventions needed. And of course, then getting the results for the policy assessment. The extension of this is, as I said, of course, doing a simulation model by system dynamics or agent-based modeling or any other techniques, which you then, of course, can also have on a nice dynamic interface on a website. So if you have enough time, you can do, of course, a lot of things. Roles and tasks in the group model building are very important. As I said, the facilitator who leads the workshop, who should be very rational, who should not participate with giving, I would see this as a variable. He's really outside and really only moderates everything. This is a very important position and task. The second is a process coach, which helps to have a look how the group evolves, how the group process takes part and evolves. So he really has the overview of all this and of course is in direct contact with the facilitator. Then, not unimportant, the modeler who do all these causal loop diagrams, understands the feedback loops and so on. And the data manager who is documenting the information during the session. So doing protocols and so on, because not in every connections you get up all the informations a person is intending with this. And of course, a lot of other roles depending on the session you use. And this is well documented in the Scriptiapedia for group model buildings, where you have a lot of ideas and can get a lot of ideas how to do this. So all nice things. The question is how, why it is system modeling is very niche, especially in Germany, for policy advice. And this we tried, of course, with help from Nicolas Böngertz, to illustrate where the decision maker and the modeler things are clashing. So the first one is that, of course, decision makers are every time interested on reducing the complexity. They have enough complexity in their life and they want to reduce it. And the modeler says, oh, we have to analyze this complexity much deeper to get the main outcome. So this one is quite in the opposite direction. The second one is that just explorative investigations and such scenario analysis aren't only explorative, are not sufficient perhaps for decision makers, and they want to have precise forecasts, although this is of course never possible for future, and especially not for complex social systems. And the modeler says we need these explorative models to test what policy might have and what policies might affect, how policies might affect the complex system. The third one is that the decision makers need very clear and very easy to understand information, which are reduced to half a page or something like this. And the modeler, of course, has to translate the very, very difficult 100 variable causal loop diagram, something like this, to very easy statements what the model is describing and where the decision makers have to pay attention. And of course, decision makers have to react quickly and do not have any big financing capacities for such models. And of course, system models to develop need time and money, depending also on if you only do the qualitative models or the very time-consuming quantitative models. So that are the more or less reasons we see. We can also discuss this later on, that the system modeling is more or less a niche in policy advice up to now, also for transformation processes. If you're interested in this and want to have a deeper look, we had this Polymod project. So it was an UBA and so on, and from the German Environmental Agency project, where we have this fact sheet, which is more or less a fact, more than one fact sheet. It's 16 pages, and tries to explain it very, very basically how to use these system modeling approaches. And also, of course, then you have the final report, but this is only available in German, where these model comparison of agent-based models, system dynamics, system thinking models, so closed loop diagrams is shown, and 2 journal papers also. So, despite all the limitations which I mentioned, I think the modeling of social aspects and the complex impact of policies in reality is very crucial for policy impact assessment. And this is especially if you're talking about radical and unknown transformation processes. So I'm in touch with some colleagues from the German Environmental Agency, and I don't know why they also do not really use such techniques, because, for example, this agency is well known to deal with complex systems and complex problems. And yeah, it's quite interesting how they do it, why they did not do it. And yeah, I like this statement: it is better to be vaguely right than exactly wrong. And that really describes system modeling, because if you do not have a deep system understanding, you think you know what to do a policy, and then you are exactly wrong at the end. And you are perhaps vaguely right if you deeper understand the system, but of course you don't know. You really don't know at the end how the policy will affect, but you have a clue what side effects you can evoke with this. And with this, I want to end up with my presentation. So before you start, I will introduce you, of course. So Professor Julio Gonzalez studied physics in Kiel, in Germany, a few days ago, and made his PhD also in natural science there, and in Norway a PhD in technology. Is a professor, or was a professor at Agder University and Gjøvik in Norway. And he's a professor emeritus since 2019. And his topics are, of course, complex systems, system dynamics, epidemiology, critical infrastructure, disaster risk management, systemic risk, which you will see in a few minutes, stakeholder engagement, and I think the latest project of you, where this interdisciplinary innovation project, where you deal with systemic pandemic risk management in the time 2020 to 2023. I think you can all imagine which topic it was. And yeah, with these words, I'm very grateful that you are here, and you have the room now.
Thank you very much for the opportunity to be here. And I was told that some of you don't speak German so well, so that's the reason we do it in English. I lived in Germany nearly 10 years, so I do speak German. And if you want to ask questions in German, that's okay. I studied physics in Germany, but not only in Kiel. I moved from Kiel to Bonn to München, and München back to Kiel. In München, I was at the Max Planck Institute when Heisenberg was the director, and he was a co-supervisor of my diploma project, together with Hans-Peter Dürr, who became the successor of Heisenberg as the director. That was a very exciting time, but on the other hand, I think Heisenberg, like many other physicists, was a little bit too early in trying to produce a theory of everything. So my decision after doing the diploma there that physics was still more complicated and one had to wait. Even today, we don't have the theory. The reason why I wanted to start with this is because you see a lot of approaches. Why so many? Is it so that you have to select one approach, or can you use all? And the answer is all are needed, because they have different purposes. So you have to think in terms of what the approach you choose in terms of its purpose. I I moved from physics to system dynamics and complex systems, owing to vicissitudes of life. And I was, in the beginning, doing quantitative modeling with system dynamics. Not only this, I also co-founded, together with two other Norwegians, a company that developed PowerSim. PowerSim is one of the tools for modeling in system dynamics, and that company still exists. I left the company many years ago, but I was with that for about 20 years. And in addition to my work as professor, I was also working as consultant for companies like Statoil, which is a major Norwegian company, Shell, but not only in the terms of energy, also in the terms of telecommunications and so on. Why did I move more to the qualitative area in system thinking? I have realized that you have to begin somewhere. And the beginning is very important because you need to engage the stakeholders. You need to engage the decision makers. Communicating the results of research is less effective than engaging the stakeholders, engaging the decision makers, engaging the problem owners. And to do that, you do need participatory modeling or group model building so that they participate in the process, because then they get a better understanding of the issues and they get also ownership of what they develop. That's their baby. And therefore, it's easier to get them to use it. But then, once you have engaged them, it's easier then to proceed to the other models. And one area that is very unexplored yet is how to change, how to use these different approaches together to extend. In the area of system thinking and system dynamics, the approach exists. It has been developed in the University of Strathclyde in Glasgow. It's called a cascading, the modeling cascade. And it has been used in areas of strategy development, but also in the area of analyzing how why major projects tend to become more costly than budgeted, sometimes many times more. I am sure you know examples in Germany. You know examples everywhere. And often they tend to take much longer time to be developed than expected. And that's an area where I am working now as a consultant. I am engaged as expert in a litigation in Norway in a project that should have cost 400 million Norwegian crowns, about 40 million euros, but it costs twice as much. So I am working with advocates and lawyers, helping them to model the reasons and so on. The other thing I want to say about system thinking and group model building is that even if it seems like it is qualitative, in a causal loop diagram, there's a lot of information that can be used also numerically, because a causal loop diagram is, mathematically speaking, a graph, a directed graph. And there's a lot of mathematics about the properties of directed graphs that you can use in order to develop strategies and analyze the result. And that's what we will do later in the workshop. Now we can change over to the arrows here. One is to forward, the other is backwards. And this one is to pointer, yes. Okay, yes. So as you can see, I am originally from Spain, but I left Spain with 17 years and stayed in Germany for 10 years, and then I moved to Norway. I founded a Center for Integrated Emergency Management, which is a priority research center at the University of Agder. Agder is the southern region of Norway, and the capital is Kristiansand, which is in Norway a big city, but Norway has only 5 million inhabitants, so 120,000 inhabitants. That's already a big city. So when the COVID pandemic started, I had retired as a professor, but I was offered an opportunity by a company to become research director for them. And then I applied for and got funding for an innovation project involving academia and users related to pandemic, to COVID. And the members of the project were the company where I was research director, a company in southern Norway called Dept. Then we had the region of southern Norway in the capital, Kristiansand, with a crisis manager and the staff involved. We had the central hospital in southern Norway. We had partners in the university from where I came, Agder University, the Center for Integrated Emergency Management. We had also 2 centers of catastrophe medicine, one in Sweden and one in Italy, that were partners. And why systemic risk? Whenever you have a system which is connected, then risks are also connected. And that means that when something happens, a risk happens, this is likely to trigger more risk. So risk becomes then a network, a system of risk. And if you read the global assessment reports from the United Nations Disaster Risk Reduction Office, the global assessment report on disaster risk from 2019 and 2022, they are all about systemic risk. And the statement that systemic risk is central for the Sendai framework, for the Paris Agreement on climate change, and for the Agenda for Sustainable Development, that you find in these reports. And they also state that the science of systemic risk is still in its beginning, in its development. So how do you define systemic risk? It is defined in many different ways. So if you look at the literature, so there are many terms, but all of them agree that systemic risk is about risk contagion, risk propagation in the system. So that means that risks are a system where a single risk can cause many other risks, a plethora of other risks, with domino effects, with cascading effects, with transboundariness, with nonlinear dynamics, and so on and so on. So how do you develop systemic risk? Again, many approaches, like strategy mapping and networks models, which is what I have done, system dynamics, agent-based modeling, scenario analysis, and so on and so on. But the key question, you want the models to be useful, usable, and use. How do you proceed? And we are back to participatory modeling, where a lot of experience shows that causes engagement. And we saw that also with our project, because it's being used by those who participated. It's being used by the capital of southern Norway, but also by the region. In German, we'll call it Land. It's been used not only for pandemics, but all kinds of issues that are important for risk, and also transcending. It's being used by the hospital. It's being used by the partners of the project. It's not being used higher up by the Norwegian government, even if they expert group that analyzed the preparedness of Norway towards the pandemic concluded as one of the main findings that the risk analysis was insufficient because it didn't consider the connection of the risk. This I have in writing. This I have used many times in approaching the higher levels. They are not interested. And that we see the problem. It's very difficult to get people engaged by telling them about results, by communicating and so on. But it is often successful if you have engaged them. Still, As you have seen later, our approach has generated interest, and it has been published by the IBM Center for the Business of Government in a report as one of the examples. And a new report is coming soon where it's also mentioned. So, strategy mapping with practitioners and power brokers. Power brokers are people who are able to take decisions or able to influence decisions. So, as I said several times, involving stakeholders in the modeling process builds strong ownership of the findings, increasing the probability of usage. But we have to include people who can take decisions because they are very busy. That means that the modeling process must be very fast. Even if you are offering quick and dirty solutions, the important point is to get them engaged. And the important thing is to change their mental models. Then other things can follow. There's a very interesting book called Escape from Modelland, which is also again as to how to, you have done things in the model, but how do you achieve usage of that? How do you change the mental model? So in order to be successful in the usage, it's important that the modeling process should be feeling transparent and relevant for those who participate. Here you see a little part of the model that we created for the pandemic. It had, believe me, millions of feedback loops. Here, there are not so many, but still perhaps more than you would expect. And here we would like to use the opportunity. Can we show the strategy finder so that I can make a little point about that? This is the same model, but I would like to make the point that even if it is a causal loop model, you have information, mathematical information that is very important. If I now use the analysis tools, and there are a lot of things that you can do with this. Remember, this is a directed graph. A graph has nodes, and the causal connections, they are directed. So that is what it is, a directed graph. If I ask about the properties, there are a lot of things that you can ask, and even more and more and more. But I am going to ask about feedback loops. And it found there are 7 feedback loops here. This you can do with many other tools. But you can see here the information that I am pointing to, potency nodes. This is just a summary, but I could go to the potency nodes here, and it says the following. Let's consider this one of the feedback loops here. Loss of trust in authority can lead to distrust in vaccination, leading to low proportion of population vaccinated effectively, leading to an increase in infection rates, leading to mutations, more virus variants, which make the vaccines less effective, which creates and reinforces distrust in vaccination. Distrust in vaccination has the potency 6. What it says is there are 7 feedback loops, but 6 of them pass here. This is a very important information for developing strategies, because if you are able to influence this and increase the people's belief on vaccination, you are killing 6 of the 7 loops that are reinforcing the risk. Another area, of course, is the low proportion of vaccinated. But you see also that the loss of trust in authorities sits in 5 of the 7 feedback loops. Again, indicating these are priorities for strategies. So the information that you have here goes beyond the feedback loops. It's telling you also where strategies should be directed in order to be most successful. Later in the workshop, we will explore these things and many other things of the analysis. Can we go back to the presentation? So what is important when you are doing participatory modeling with this tool that you show now, Strategy Finder, is first of all, you identified the composition who should contribute in the modeling. And you need proud owners, you need stakeholders, people who have an interest in the issue. You need people who are able to take decisions or influence decisions. And then basically you have 4 stages. Drafting the risk model is the first stage. Quality assuring validation of the model. And once you have achieved that, strategy development and strategy implementation. How many workshops do you need to that? Well, at least 1 per stage, but often you have to iterate, so it can be twice as many. And they are designed to about 90 minutes. Remember, they are very busy, the people you want to involve. You have to be very fast. So we have workshops for about 90 minutes each one. Then you need to analyze, as a facilitator, you need to analyze the results, prepare the next workshop, and so on. In practice, that can go over months, workshops with distances of 1 or 2 weeks. It depends very much on how busy the people are. In principle, you can conduct a workshop today, analyze tomorrow, next workshop, the next afterwards. But in practice, people are very busy and having an agenda with them is difficult. In the project that I mentioned, the Systemic Pandemic Risk Management, we identified the key interconnected subsystems. And each of the systems needs to be analyzed for impactful and practical strategies. You need strategies that are impactful, that have effect, but they should be also practical. You should be able to implement them. Both are necessary. But it is also very important that the strategies are understood. If you don't understand the strategies, you cannot implement them and you cannot monitor them. And then you need to identify who is responsible for each of the strategies. All these things are needed. Here are the main results of our project. There are subsystems that are very important for the pandemic, for any pandemic, especially for COVID. For instance, a subsystem about trust in the authority, or the overload of information called infodemic, collaboration, shortage of healthcare workers, low proportion of people vaccinated and so on. All these are interrelated. The lines are not causal in the sense that they say you this goes in this direction or the other. Rather, there are many causal connections indicated by each of the lines. And all of them affect the infection rate of the pandemic, but also the indirect effects of the pandemic, because the hospitals were so busy that people perhaps needing a cancer surgery couldn't be attended. And people got also depressed. You had an increase in depression and so on and so on. The important thing here is, if you look at this, were all these systems addressed in the strategies? And the answer is no. Not even in the countries that did best did all address that. But you need strategies for all of them. You need strategies so that healthcare workers stayed on the job. Several people I knew, young doctors, gave up because they say, we don't have a life. I have to get up at 5 o'clock in the morning, come back at midnight. I don't see my family. I don't see my kids. So several of them gave up. Others got sick and couldn't help and so on. So you have to address this, but you have to address the vaccination. You have to address the secondary consequences, mental health and so on, because it's all interconnected. And our model was like this, and it is only one of the view. If you look here, you see many views. Each of these is a view of the system, because we don't analyze the whole spaghetti, but we identify the key issues and identify them and develop strategies for the key issues. What you see here is actually already a development of strategies. We identified the strategies in purple to be those who are most effective and practical. And then what we produce were portfolios of strategies for the shortage of healthcare workers in hospital subsistence. We agreed on a number of strategies, their purpose and implementation team. So one strategy was establish high-level infection protection for healthcare and emergency workers in order to directly avoid shortage of healthcare workers in hospitals and control local outbreaks in hospitals and to avoid having exhausted healthcare workers and so reduce possibility of low productivity of working healthcare workers and so on. That's the rationale. You have to understand that. And that you read from the model. Who is responsible? Implementation team is chief physician at short-term nursing home or a hospital contingency planner. And that's another strategy and another strategy. Why several strategies? Because no strategy is 100% effective. So you need portfolios of strategies. And that was one subsystem. There is another subsystem, and there were several pages. They were agreed with stakeholders and implemented in the city and in the region. Here is a report which is written for decision makers, published by the IBM Center for the Business of Government, addressing complex and cross-boundary challenges in government. The value of strategy mapping. Strategy mapping is the name for what we are doing, developing strategies. It's easy to read, and I can recommend that. So strategy mapping using participatory modeling has achieved useful, usable, and used results. As I said, in Kristiansand and the region of southern Norway, they have been using it for after the project for preparedness and resilience toward major challenges, including climate change. And there is a growth in the use of strategy mapping, systemic risk in disasters, systemic risk related to climate change and sustainability, in systemic risk in large and complex projects. But also in strategy development towards positive goals, like, for instance, companies achieving competitive advantage. And what we still have left as a big research challenge is the multi-modeling, combining the different approaches. Among the references, here is the report. It can be, just go to the webpage of the IBM Center for the Business of Government, and there you find the report. It was published the 5th of January in 2023. But there is a paper, I misspelled my name, Accounting for Systemic Risk in Analysis of Crisis Scenarios, in the Conference of Information Systems and Crisis Response and Management in 2024. It was in Münster. And other references, Abisnes and Paulsen, they are staff from the city of Kristiansand. And we had a paper, a practitioner paper, Improving Resilience Against a Pandemic, and novel technology for strategy development with practitioners and decision makers. There's a very good book about strategy mapping by Ackerman and Eden, two top cited scientists with, I think Eden has more than 30,000 citations and H-index 75 or something like this. Making strategy, mapping our strategic success. I have collaborated with Colin Eden for about 20 years. And one of our papers is the strategic management of disaster risk mitigation, or devising mitigation strategies with stakeholders. Thank you very much.